Sir.
Yes. Yeah, somebody saying something? So in the last class, we discussed that there is a main memory and there is a processor, and to run processor fast, I mean getting the instructions and data fast enough, we put something what we call what? Cache and processor. I hope you remember this structure and the reason, although I mean we'll be discussing that on a greater detail, but I hope you would be remembering the reason of having a cache in place. Yes or no?
Yes, sir.
Yes, sir.
Okay. So cache here, and a similar idea is also used that you call, I don't know whether you have heard this or not. There is something called virtual memory. Have you heard this? Hmm? How many of you have heard this idea, virtual memory?
I have heard. I have heard, sir.
What is this? Can you tell me?
Sir, I don't know for exactly what it is, but while using Windows, it assigns some virtual memory that can be used, I think, as RAM or something.
Somebody is saying I am not audible. Siddharth Kumar. There may be a problem on his system or something like that because others are able to listen. Yeah. So you were saying something about this thing, virtual memory. What you were saying?
So I was saying I don't know for sure, but I think some space of, I don't know if hard disk or something is can be, I think, used as RAM. I don't know for sure, but while using Windows, it gives some virtual memory. It divides some of the space into virtual memory.
Why are you so apprehensive about being wrong? At most you will be wrong, nothing else. And by the way, you are not wrong. What you are saying is right.
So I haven't read about the concept. I just know from using Windows.
That is okay. So why you are apprehensive about this? Let it be wrong.
Okay, sir.
I mean, don't have any apprehension that what if I will be wrong. At least you are, daring enough to answer the question. So that is perfectly fine. So what you are saying is correct. So the role cache plays with memory, the similar kind of role hard disk, part of hard disks when plays with memory. So because memory is expensive and the hard disk is cheaper. So the same thing that we are doing with memory and cache, same thing can be done with a part of hard disk and memory. So this part of hard disk is termed as virtual memory. So it is not actually the main memory, but because it is being used as main memory, so that's why we call it virtual memory. And there is a whole concept that we call virtualization, but the concept wise virtual memory and caching, they are pretty much similar, although we are going to discuss both in coming classes. But yeah, I just mentioned it because it is similar to that. Fine? Do you understood what I'm saying?
Sir, so it means that if we don't have any hard drive, then we can't allocate any virtual memory.
Say again, please.
Means if we don't have hard drive, then we can't allocate any virtual memory.
Somebody is writing here or what? Somebody is writing here, so I don't think you should write on this. Who is writing? There is no possibility of virtualization. Right? Is it okay?
Yes, sir.
A computer can be improved. So there will be few things that we'll discuss in small details. One is processor clock. So can somebody tell me how processor clock can help in increasing the speed?
So processor clock is the same thing that sort of gives signals to the processor to time the instructions, right?
Okay. So
So
suppose.
I'm asking you, is it its function?
Huh?
I'm asking you, is it its function? What I've said.
What did you say? Please say it again.
I said, is processor clock the thing that gives clock pulses and signals the processor, signals the control unit to schedule the instructions?
Yes, exactly. So, I mean, there is a processor clock that's like kind of heartbeat to you.
Increasing the clock frequency would increase the processor speed.
So, this guy, whomsoever you are, what is your name?
What, sir? Can you repeat?
What is your name?
Aditya, sir. Aditya Jha.
So, Aditya is saying increasing clock frequency means increase in speed. Is this what you are saying? Or performance?
So number of instructions performed would be increased, I guess, from what I know.
Can we say it in general or it's a restricted statement?
So because I don't know the...
yeah, somebody else is saying something. Yeah, please speak up.
By increasing the frequency, just clock pulses per second will be increased.
Right.
Not the
so
processor
will it increase the performance always or something else to be done or there is a limit?
Something else to be done, no, sir. It just increases the clock pulses per second.
What should be done and why this will not do all the things?
We'll just increase the clock pulse because of CPU, sir. That's it. It
is a clock for CPU only. It's not more likely. It is a clock for CPU only. That's right.
But it won't increase the performance. It will just tell the time for the.
No. Sorry. I mean, you are saying about that. No, it's not that. It is actually what is happening. You are doing.
What would be the? Yeah, sir. What I was saying that clock frequency would increase the instructions that could be performed in one cycle, but we need to sync other devices to its frequency too. Just simply increasing
like
it
this.
won't work.
Suppose this is my read operation. And let's say this has to be performed in 4 clock cycles. There is a clock cycle that has to tell that where 4 has happened. So there it's like a clock pulse. So it has to be done in 1, 2, 3, and maybe 4 clock cycles. There should be a clock that should tell when these 4 will happen. So I mean in computer everything happens with a clock pulse. So it's not that because everything is synchronized and all that. Right? Is it right? So every instruction has to be executed on the basis of clock pulse, and in one clock pulse, a part of instruction will be executed. That generally called as micro operation. So a part of micro operation has to be executed. Are you getting this point? So what I am saying is like this. for this one clock pulse, one micro operation. Sorry. One micro operation. OPN stands for operation. Right. So if we are squeezing the clock, so for example, if we are making clock like this, will it increase the performance? Or maybe like this?
No, sir.
Why?
So because performance will like it is like for time we will say it is taking 6 seconds or 6 cycles, but it is actually taking the same time. Like the read graph is same. It is not change affected by the change in the clock speed.
So what Manasa? Probably Manasa is saying something?
No, sir. Sanya.
Sanya.
Yes, sir.
So what Sanya is saying is partially correct. So it's not only the squeezing of the clock speed that will make it fast, because a micro operation has to be executed in that clock duration. If you will squeeze without working out with micro operation, and if you will squeeze it, micro operation will not be executed in that clock cycle and it will be overflowed. So ultimately that will lead to the instability of the system. And if you are, you are squeezing your micro operation but not squeezing the clock cycle, you are getting something on inefficient. So whenever we talk about this, so whenever we talk about this, there are two things that has to be done while squeezing the clock cycle. What may be these two things? Can you tell me?
So could you repeat the question?
I am saying if I want to squeeze the clock cycle, what I actually have to do? So one thing is I have to work with IC technology to make logic circuits. I hope you understand logic circuits.
Yeah, sir.
Yes.
Yes, sir.
Logic circuits faster. That is one thing, right? So if you are squeezing this logic circuit execution time, you can reduce the clock speed. And second thing is you have to design your steps in such a way. Steps should be. So when I say steps, I mean micro operation. Micro operation steps should be designed in more efficient way, right? You getting my point? So in a way, in both the cases, you are actually speeding up your system, right? Is it okay? Hmm? Is it okay? You're getting my point?
Yeah, sir.
So I am just writing on the basis of that, I am just writing a basic performance equation. So T is generally referred as the performance parameter. That is equal to N multiplied by S divided by R. So what N, S and R is? R is your clock rate. Okay. Okay.
Clock rate means number of clock pulses. Is clock rate mean number of clock pulses?
Yeah, so when you say 500 megahertz computer or 1 gigahertz computer or 2 gigahertz computer or things like that.
Okay.
And S is the average, average micro operations per instruction. Understand this? So there are multiple instructions in instruction set, and all instructions will be having a different number of micro operations required. So what is the average number of micro operations required? That will be actually termed as average that is actually S. So average micro operations per instructions is S. Understood?
Yes, sir.
And so, I mean, you can also say average micro operations per instructions, or you can say average clock cycles per instruction. Right? Because one clock cycle is being consumed in one micro operation. Right? Is it okay?
Yes.
And N is the number of instructions to be executed. N is the number of instructions to be executed. Yes, please. Somebody saying something?
आज का रिवीजन कैसा रहा आप लोग का हिंदी का?
क्या बोल रहे हैं? समझ नहीं आ रहा।
हम डिस्कस करेंगे आपके आंसर शीट्स को। Tomorrow I'll take one combined class at 2:30. Where I'll be discussing all the papers.
Are there more than one instructors in the class? Who is speaking?
No, sir.
अभी कोई बोल रहा था ना कुछ? Hello.
Sir, a case of accidental mic. Someone had accidentally unmuted the mic.
It looked like some teacher was saying something. Okay, anyway. So is this okay? Is this okay?
Yeah, yeah.
So to execute the application program, this is the time required. So whenever you are using you are trying to use a clock to speed this up, you have to actually work in a way that this t should decrease. If this t will decrease, then you can say that for this particular kind of setting, this clock cycle is the best. Sorry, this clock speed is the best. Right? You're getting my point?
Yes, sir.
Any confusion in this?
No, sir.
Now let's move on to other thing. So suppose this is my time axis, and of course this is only one axis that we are talking about. So when one instruction has to be executed, execution of one instruction, what has to be done? For execution of one instruction, you have to fetch the instruction, right? Fetch means you have to bring that instruction from memory to the processor so that that can be executed lately.
Yes.
Right. Then maybe you have to execute the part of instruction. Or I mean, when you are talking about instruction, that won't be actually the part of instruction. And then you have to fetch the data. Right? Then execute the instruction. And then probably store the result in the memory or send the output, store the result, or send output to output device. Right? So when I say that I have to execute an instruction, probably this all I have to do. These 4 steps maybe. Is this okay?
Yes, sir.
So if I am talking about this whole time where I am saying that this will be instruction execution time, part of this may be for this, if this is first activity, will be used probably for the first activity. Part of this probably will be used for second activity. Part of this will be used maybe for third activity. And part of this may be used for fourth activity. Right? Is it okay?
Yes, sir.
If you'll see more clearly, you will actually figure out that only this is the part when your processor is busy. The rest of the times, processor is actually not busy. Right?
Yes, sir.
So probably when instruction is being fetched out, this time can be used for another instruction to execute. So maybe some instruction can start little earlier to this. Here 1 and 2 may happen, 3 may happen here, and 4 may happen here. Right?
Yes, sir.
So in a way, if I am not doing this, my processor is busy for this whole duration, for a single instruction. But actually, he is busy for only this much duration. I mean, it looks like processor is busy till, if I'm calling it T0 to T1. So it looks like processor is busy till T0 to T1, but actually it is only busy to, if I'm calling it T2 to T3. It is actually only busy to T2 to T3. While if I am doing this kind of thing, I am adding another instruction and maybe another instruction can be added here, maybe here. So in that case, my processor is most of the times actually busy and I am able to run the concurrent instructions without affecting things. Right? You're getting my point? So what I'm actually doing, I'm partitioning the instruction into parts, into small subparts, and executing multiple instructions simultaneously. Right? You're getting my point? आप क्या कर रहे हैं, आपके इंस्ट्रक्शन को आप छोटे पार्ट्स में बांट रहे हैं और उनमें जो प्रोसेसर एग्जीक्यूशन का टाइम है उसको तो कंकरेंट नहीं कर रहे हैं लेकिन बाकी चीजों को कंकरेंट कर रहे हैं. समझ में आ रहा है? जैसे लेट मी ड्रॉ इट फॉर ए मोर क्लियर पिक्चर. जैसे ये इंस्ट्रक्शन 1 है, इसका ये टोटल एग्जीक्यूशन टाइम रहने वाला था. आई एम मेकिंग 3 पार्ट्स. इसमें ये खाली ये वाला पोर्शन है जो प्रोसेसर के लिए यूज होने वाला था. तो व्हाट आई एम एक्चुअली डूइंग, दिस इज इंस्ट्रक्शन 1, आई एम यूजिंग इंस्ट्रक्शन 2. तो जब ये इंस्ट्रक्शन एग्जीक्यूट कर रहा है उस समय दूसरा इंस्ट्रक्शन फैच और डिकोड में लगा है. आई एम अगेन मेकिंग these parts. So ये जो मैं शेड कर रहा हूं वो प्रोसेसर वाला पार्ट है, यानी एग्जीक्यूट वाला. एंड लाइक दिस. मेरा बोर्ड थोड़ा छोटा है, सो जस्ट assume that it is going like this. ठीक है? So in a way I am saving this time. I am saving this time. In a way I am saving this time. ठीक है? So will it not fast my system? Will it not improve the performance of my system? Will it or will it not?
It will.
Hmm?
Yes, sir, it will.
So this particular idea is called as pipelining. So you are making a pipeline of instructions where you are putting the instructions and executing them one by one. ठीक है? Is it okay? Are you able to appreciate?
Yes, sir.
Yes, sir.
What has to be taken care of while pipelining? Can you suggest some things to me?
Sir, fetching of next memory of the next instruction, this sort of fetching the memory of the data, because as soon as this gets over, we have to start the next instruction.
Okay.
Execution of the instructions must not overlap.
Okay. So one thing is very clear, probably you can appreciate that easily. Though I have made this shaded part almost equal, तो मैंने जो भी ये shaded part बनाया है, ये वाला part, ये देखने में शायद आपको equal जैसा लग रहा होगा, but will it be equal in real sense?
Actually, no.
No, sir. It may.
It will not be equal. It will be different for different instructions. So in a way, we have to understand this, that we have different time steps available. अच्छा, इसमें भी ये भी हो सकता है कि ये वाला जो पोर्शन है, ये किसी में छोटा हो, ये वाला पोर्शन बड़ा हो, ये भी हो सकता है. So these are not equally distributed. यहाँ पे देख के ऐसा लगता है कि अगर ये total t duration है, तो मे बी ये t by 3 है, ये t by 3 है और ये t by 3 है. But actually it is not true. It is nowhere equal and you don't actually, you cannot say कि ये सारे instructions में equal होगा. आप ये भी नहीं कह सकते कि एक instructions में equally divided होगा. So you have to make sure that doing all this, no instruction execution should overlap to each other. यानी एक instruction already चल रहा है, दूसरा instruction भी execute होने लगा. ऐसा नहीं होना चाहिए. That is one thing. The more complicated problem is second. It is possible that this guy is using some variables and this guy is also using some variables. तो ये इसके लिए जो वेरिएबल यूज हो रहे हैं और जो इसके लिए जो वेरिएबल यूज हो रहे हैं, वो वेरिएबल्स एक दूसरे को अफेक्ट नहीं करने चाहिए, बिकॉज दे आर इंडिपेंडेंट इंस्ट्रक्शंस, राइट? As long as we deliberately want so, they should not affect each other. Is it okay?
Yes, sir.
Yes,
So
sir.
this problem I'll discuss in detail, and those who have already read through my operating system, they probably would have seen that synchronization. This problem is called as synchronization. Can somebody from CS, some Nitesh, don't do that. Nitesh. Who is Nitesh? Who is Nitesh? So is there somebody who has read through operating system and can tell us synchronization?
Sir, we read it within the context of multiple processes like inter-process
It is
communication.
actually that only, beta. It is actually pretty much that only.
Is that actually here you are talking about instructions? So like instructions could be of one process also.
Yeah, so I mean the idea is pretty much same. So those who have not read through synchronization, we'll discuss it in this class as well. But the idea is one process, one instruction execution variable should not affect another instruction execution variables. So that has to be kept into mind. But other than that, this is a very good idea. This pipelining is a very good idea, and your pipelining makes your system pretty fast. So you have a pipeline of instructions where you are putting instruction and taking it out, putting another instruction and taking it out. This is an execution pipeline. Right? Is it okay? So your processor has an execution pipeline where you are putting an instruction every time you are getting it executed. So in this portion, the shaded thing will come. of that instruction. So this is a pipeline where you are putting this kind of instruction and certain thing is coming and that is getting executed. You're getting my point?
Yeah, sir.
Okay.
Sir, but all the instructions are actually subdivided. So how
Yes.
that happened?
Actually, instructions are originally subdivided. So when you say, when you give one instruction that already has micro operations within itself, you just have to figure out what micro operations can be used as overlapped micro instructions. तो आप कहां पर स्पेस ये आइडेंटिफाई कर सकते हैं आपको ढूंढना है बट दे आर ऑलरेडी डिवाइडेड इनटू माइक्रो ऑपरेशंस राइट
Sir, so only that part goes into actually microprocessor.
Yes. So the idea is, I'll just give you a very, generic example. The idea is कि जहां पर भी आप कुछ टाइम ऐसा यूज कर सकते हैं जहां पर दूसरा इंस्ट्रक्शन एग्जीक्यूट किया जा सकता है वहां आप उस जब करते हैं उसको और प्रोसेसर को खाली प्रोसेसर वाले टाइम के लिए यूज करते हैं तो आप उसको कहते हैं पाइपलाइनिंग राइट
Yes.
Is it okay for everybody?
Yes, sir.
So actually we are kind of creating pipeline and this is what we are calling as pipelining. अभी अगर हम ऐसा करें कि हमारे प्रोसेसर में हम एक से ज्यादा पाइपलाइंस क्रिएट कर दें यानी प्रोसेसर में कुछ इस तरह की कैपेबिलिटीज हों कि वो एक साथ 3 इंस्ट्रक्शंस का एग्जीक्यूट पार्ट एक साथ कर सकता है सो दिस इज मे बी पाइपलाइन 1 दिस मे बी पाइपलाइन 2 दिस मे बी पाइपलाइन 3 अगर हम ऐसा कर पाए तो फिर हम उसको कहते हैं सुपर स्केलर एग्जीक्यूशन ठीक है सो दिस इज कॉल्ड एज सुपर स्केलर एग्जीक्यूशन तो एक्चुअली हमने यहां पर दो चीजें की एक तो हमने हमारे इंस्ट्रक्शन के एग्जीक्यूशन में जो फ्री टाइम था उसका यूज किया और फिर हमने हमारे प्रोसेसर को एक से ज्यादा चीजों को एक साथ एग्जीक्यूट करने के लिए प्रो किया ये दो चीजें कहलाती हैं पाइपलाइनिंग एंड सुपर स्केलर एग्जीक्यूशन इन दोनों का रिजल्ट ये है कि योर सिस्टम परफॉर्मेंस इंक्रीजेस अ लॉट आप लोगों में जिन्होंने ये सुना है कि पहले 486 सिस्टम्स होते थे फिर पेंटियम सिस्टम्स आए तो पेंटियम सिस्टम्स का एक एज ये था कि उनमें सुपर स्केलर एग्जीक्यूशन और पाइपलाइनिंग प्रपोज किए गए थे पाइपलाइनिंग तो इनफैक्ट पहले आ गया था सुपर स्केलर एग्जीक्यूशन एक्चुअली केम फ्रॉम पेंटियम सिस्टम्स so that's the history I'm not going to talk much about that
So could you explain super scalar execution once again?
basic idea is it okay or not
Sir, can you hear me? Sir, am I audible to you?
Yes, you are audible, but I could not listen you properly.
Yeah, sir, I was saying, could you just explain super scalar execution once again?
सुपर स्केलर एग्जीक्यूशन का मतलब इतना ही है कि अभी आपने क्या किया था आपने आपके इंस्ट्रक्शन को 3 पार्ट्स में बांटा था जो कि वो ज्यादा पार्ट्स भी हो सकते थे मैंने एग्जांपल दिया तो उसमें 3 पार्ट्स बताए थे आपको फैच एग्जीक्यूट एंड स्टोर ठीक है
Yes.
उसमें जो एग्जीक्यूट वाला पार्ट था वो प्रोसेसर एक टाइम में एक एग्जीक्यूशन कर रहा था ठीक
Yes.
वो प्रोसेसर को ऐसे 3 पार्ट्स में डिवाइड करता है जिसमें से एक पार्ट एक एग्जीक्यूशन करे दूसरा पार्ट दूसरा एग्जीक्यूशन करे और तीसरा पार्ट तीसरा एग्जीक्यूशन करे तो इन ए वे वी आर हैविंग मोर देन वन पाइपलाइंस अवेलेबल टू अस
Yes.
If it so happens we call it super scalar execution
Okay.
got the point
Yeah, sir.
any confusions for anybody? Huh?
No,
No, sir.
Sure?
yes.
ठीक है ये?
Yes.
Another idea is the size of instruction set. So, okay, let me first get to the new slide. Size of instruction set. So there are two possibilities. One, you have a small instruction set. And you can have a large or complex instruction set. Can you tell me how this will actually affect the things?
So affect what? What? What should it affect? What was the question?
So how small instruction set and large instruction set will actually differ in terms of speed? How it will differ the performance?
So a small instruction set, I guess, would have yes execution time. It would have a yes execution time.
It would have
less execution time.
why?
Because we need to perform lesser instructions.
Yeah, that is right. तो इसका मतलब हमें इंस्ट्रक्शन सेट बहुत छोटा रखना चाहिए.
Not
It depends
necessary.
upon
It
the
would
problem.
depend.
It depends upon problem what we are
Yeah.
going to program.
ओके सो दो तरह की बातें हैं यहाँ पर. अगर हमारा इंस्ट्रक्शन सेट छोटा होगा तो ये तो पक्का है कि वो सिंपल इंस्ट्रक्शंस होंगे और उनका एग्जीक्यूशन कम टाइम लेगा. लेकिन फिर अल्टीमेटली इंस्ट्रक्शंस एग्जीक्यूट करने हैं क्या? अल्टीमेटली तो हमें एप्लीकेशन प्रोग्राम एग्जीक्यूट करना है और उसको एग्जीक्यूट करने के लिए ज्यादा बार उन इंस्ट्रक्शंस को एग्जीक्यूट करना पड़ेगा. इज इट नॉट? यू गेटिंग माय पॉइंट? आपके पास खाली सिंपल इंस्ट्रक्शंस हैं थोड़े से, तो आपको अगर कोई प्रोग्राम रन करना है तो उसके लिए आपको उन इंस्ट्रक्शंस को ज्यादा बार यूज करना पड़ेगा, ज्यादा ट्रिकी प्रोग्राम लिखना पड़ेगा. जैसे अगर आपके पास मैट्रिक्स मल्टीप्लिकेशन का कोई इंस्ट्रक्शन है दैट यू विल नेवर हैव एक्चुअली, बट अगर आपके पास मैट्रिक्स मल्टीप्लिकेशन का कोई इंस्ट्रक्शन है तो यू कैन सिंपली राइट वन थिंग मल्टीप्लाई मैट्रिक्स ए टू मल्टीप्लाई मैट्रिक्स बी एंड यू विल गेट द रिजल्ट. अगर आपके पास ये इंस्ट्रक्शन नहीं है तो देन यू हैव टू डू अ लॉट ऑफ एडिशन एंड मल्टीप्लिकेशन ऑपरेशंस विद अ ट्रिकी वे so that you can perform the matrix multiplication. Is it right or not?
Yes, sir. Right.
तो स्मॉल इंस्ट्रक्शन सेट का जहां ये फायदा है कि वो सिंपल है, इजी टू हैंडल है. नुकसान ये है कि उसमें प्रोग्राम्स लिखने के लिए आपको ज्यादा कॉम्प्लेक्स चीजों की जरूरत पड़ती है. वेयर जब आप लार्ज या कॉम्प्लेक्स इंस्ट्रक्शन सेट्स पे जाते हैं तो वहां पर ज्यादा इंस्ट्रक्शंस अवेलेबल हैं, लेकिन फिर उनका एग्जीक्यूशन टाइम पर साइकिल वो बढ़ जाता है. So on that basis, there are two kind of systems that we have: RISC. Sorry, it's not S, it is C. It is CISC. So RISC stands for Reduced Instruction Set Computer, and CISC stands for Complex Instruction Set Computer. So both the kind of systems are in practice. Both have their advantages and disadvantages. So we have to have a trade-off where we can use these, right?
Yes, sir.
Yes, sir.
Okay. Another thing now that comes is compiler. So how compiler will affect the execution, the performance? Can you tell me?
Number of instructions it could decode in one cycle could be increased.
Compiler is not going to do that, right? What compiler is going to do? Somebody tell me. What compiler is supposed to do? Can anybody tell?
Convert the source code into object code,
What do you mean by object code?
which can be readable by machine.
Binary.
So what is actually happening? What compiler is actually doing?
Translating our language into that.
With context of this course, what compiler is actually doing? Can you tell me? So compiler is doing nothing but converting your program into instructions. So ultimately what compiler is generating is the form of instructions. You're getting my point? Instructions that comes from the instruction set of a particular processor. Is it okay? आपको ये बात समझ में आ रही है कि नहीं आ रही?
No, sir. Can you just repeat? Can you just repeat this one? What did you just say?
Let me write it. This is my, let's say, compiler. It is taking the program, let's say in C, if it's a C compiler. And what it will generate as output? It will generate a sequence of machine instructions. ठीक है?
Yes, sir.
So actually what it is doing, what you call object code or what you call binary, what is actually that? That is the sequence of machine instructions that actually a machine understands, that the instructions that a machine can fetch, decode and execute. Right?
Yes.
Everybody is able to understand this? Is it okay? So how compiler will come into picture for performance?
हेलो
Yes, please.
कुछ नेटवर्क प्रॉब्लम आ गया था वहां पे क्या लिखा था आपने सीक्वेंस ऑफ
Sequence of machine instructions. MC stands for machine.
ओके थैंक यू
तो अभी कंपाइलर कैसे यूज होगा इसके लिए ये बताइए.
Compiler कैसे यूज होगा वो या फिर how it will help in pipelining.
Yes, how a compiler will be actually improving the performance. how a compiler will play a role into that.
Sir, it can reduce our code written in our high level language to a small instruction set or large or complex instruction set. It would depend on that, right?
ये reduced instruction set है या complex instruction set है, वो तो processor की property है, इसका compiler से कोई लेना देना नहीं है। तो वो प्रोसेसर कैसा है वो फिक्स है और कंपाइलर उसके लिए डिजाइन है। अगर कंपाइलर ऑप्टिमली डिजाइंड होगा तो वो जो कन्वर्जन करेगा वो इस तरह का कन्वर्जन करेगा कि जिसमें आपको मिनिमम प्रॉब्लम्स हो।
यस सर।
अगर आपका कंपाइलर ऐसे ही होगा, उतना अच्छा नहीं होगा, तो फिर वो शायद उतने अच्छे से नहीं कर पाएगा। So an optimal compiler will be something that will be generating a code that is optimal in size. So you need something, some compiler that can generate the code of optimal size. That's what the point is. You getting the point? Huh?
So how does it? How is a compiler optimal? What can it do? The question.
So that will actually depend on the design of compiler. तो किसने कंपाइलर बनाया, उसने बनाते वक्त उन चीजों का ध्यान रखा कि नहीं रखा, या उसने खाली एक प्रोग्राम ट्रांसलेट हो जाए उतना ही ध्यान रखा। दिस इज द इम्पोर्टेंट पॉइंट।
Sir, what are the factors?
Could you give a? Yeah, Rahul, go ahead.
Yes, sir. What are the factors that contribute in the?
Okay, so कंपाइलर पढ़ेंगे, किसी ने कंपाइलर पढ़ा है तो कंपाइलर में डिफरेंट मेथड्स होते हैं जिसकी वजह से वो कंपाइलर पूरे कोड को बार बार देखता है और उसके बाद उन इंस्ट्रक्शंस को कन्वर्ट करता है। तो उन इंस्ट्रक्शंस को कन्वर्ट करने के अलग अलग तरीके होते हैं। वो तरीकों में से कौन सा तरीका सबसे अच्छा है, दैट विल एक्चुअली गिव यू द बेटर कंपाइलर और द वर्स्ट कंपाइलर। The basic idea is if a compiler is better written, because compiler itself is a program. So if compiler is better written, the kind of output you will be getting, that will be actually better. You're getting it?
Yes.
You're getting my point? What I am trying to say?
Yes.
No कहने वाले बताएं, yes कहने वालों में मुझे कोई इंटरेस्ट नहीं है। I am interested in listening to those who are saying no. मेरे इंटरेस्ट का कोई भी नहीं है आपकी क्लास में।
So could you maybe give a brief or elaborate upon the specific things that a compiler can do that would reduce?
Specific thing मतलब आप ये समझना चाहते हैं कि उसके कंपाइलेशन का प्रोसेस क्या है?
सर हाँ, ब्रीफ में कि मतलब कैसे सिर्फ ट्रांसलेशन एक जो खराब वो डिजाइनर होगा वो सिर्फ ट्रांसलेट कर देगा, वो समझ में आया, बट जो अच्छा होगा वो कहाँ कहाँ ऑप्टिमाइज कर सकता है, मतलब ऑप्टिमाइज करने का स्पेस कहाँ है प्रोग्राम में, वो
हम लोग बाद में डिस्कस करेंगे। अभी ये इमीडिएटली इस कोर्स का फोकस नहीं है, बट इमीडिएटली मैं इतना आपको कह सकता हूँ कि जो आपको शायद इसमें बहुत टाइम नहीं लगेगा और आपको शायद कुछ समझ में आएगी उसमें बात, because understanding this process will require a complete course, and I hope you have a course like compiler design in this semester. Yes or no?
Not in this semester.
तो क्या नेक्स्ट सेमेस्टर में है? कब है करना है? इसके बाद तो सेमेस्टर बचे ही नहीं है।
So we are in fourth sem, right?
ओके नहीं, थर्ड ईयर वाले बच्चे भी हैं। अच्छा, वो लेकिन इसी के हैं तो वो शायद तो कंपाइलर में हम जब प्रोग्राम डालते हैं तो कंपाइलर सबसे पहले क्या करता है, उसमें से उन वर्ड्स को रिमूव करता है जो कमेंट्स हैं, फिर उसके बाद कुछ डायरेक्टिव्स को रिमूव करता है। उन डायरेक्टिव्स को रिमूव करने के बाद फिर वो जो आपके प्रोग्राम के ग्रुप्स हैं, छोटे छोटे ग्रुप्स बनाता है, फिर उन ग्रुप्स को वो कन्वर्ट करता है मशीन इंस्ट्रक्शंस में। अब वो ग्रुपिंग प्रॉपरली हुई है कि नहीं, एफिशिएंटली हुई है कि नहीं, उसका जो कन्वर्जन मैकेनिज्म है वो एफिशिएंट है कि नहीं, ये सारी चीजें एक्चुअली डिसाइड करती हैं कि कंपाइलर ऑप्टिमल होगा, एफिशिएंट होगा कि नहीं होगा। ठीक है। अब ये हो सकता है कि आप ऐसा कंपाइलर बनाने में उसे बहुत ज्यादा कॉम्प्लिकेटेड बना दें तो एग्जीक्यूशन बने कंपाइलेशन में बहुत ज्यादा टाइम देने लगे, देन इट इज अनदर काइंड ऑफ आई मीन inefficiency. You're getting my point, what I'm trying to make?
Yeah, sir, a bit.
Okay. So eventually when somebody will discuss compiler with you, you'll be more aware to that. But the point I'm trying to make here is if it is a well-written compiler, you'll be getting a better output and that will actually lead to the better performance. Right? ठीक है ये?
Sir, can you give an example of a well-written compiler of any language?
नहीं, अभी इस तरह के एग्जांपल्स देना आपको मुश्किल है क्योंकि जो इनएफिशिएंट कंपाइलर्स हैं या जो एफिशिएंट कंपाइलर्स हैं वो बहुत और चीजों पर डिपेंड करते हैं, तो उसके बारे में एग्जांपल अभी देना बहुत इजी नहीं रहेगा. Probably that will be discussed in the course of compiler.
Okay, sir.
बट बाय एंड लार्ज इतना कह सकते हैं कि कंपाइलर, कुछ कंपाइलर्स होते हैं जो जनरल पर्पस कंपाइलर्स होते हैं, तो उनको जब आप इंस्टॉल करते हैं किसी मशीन पर तो वो उसके हिसाब से इंस्टॉल हो जाते हैं. कुछ कंपाइलर्स होते हैं जो स्पेसिफिकली मशीन के लिए डिजाइन होते हैं. अल्टीमेटली कंपाइलर इंस्टॉल होने के बाद मशीन इंडिपेंडेंट ही रहता है, लेकिन उसका जो इंस्टॉलर है वो ज्यादा जनरल है, ज्यादा स्पेसिफिक है. दैट विल ऑल्सो मेक्स अ डिफरेंस. तो अगर ज्यादा जनरल इंस्टॉलर है तो फिर वो शायद उतना ऑप्टिमल नहीं होगा, बट देन दैट कैन बी मोर वाइडली यूज्ड. लेकिन जो स्पेसिफिक कंपाइलर्स डिजाइन किए जाते हैं वो थोड़े से ज्यादा एफिशिएंट. Probably what I am trying to say may look little out of your set of knowledge, but for now I can say this much. ठीक है?
Yes.
So should I go ahead?
Yes.
Now, हमने इतनी सारी बात की परफॉर्मेंस के बारे में, अभी तक परफॉर्मेंस की रेटिंग क्या होगी उसके बारे में बात नहीं की. So there is something called SPEC rating. So SPEC stands for System Performance Evaluation Corporation, SPEC. So there is a non-profit organization, SPEC, that gives the rating. So SPEC rating is equal to running time on reference computers divided by running time on computer under test. है ना? Is this fine? Is this fine?
Yes, sir.
No, it's not fine actually. Running time of what? So running time of what?
Some pre-decided specific instructions.
On pre-decided specific program, but what is that program? So it will vary. So for some programs, some system will perform better, and for other programs, that system will not perform that better. So what we are talking about?
So they might take some standard instructions that a lot of instructions that generalize most of the instructions, and then they can give a rating.
So what actually we do, we have a group of programs, group of test programs. Right? You compute SCPC rating for all of these, and for IF program you call it SPEC I. And finally, it is computed by taking the harmonic mean of all of that. So SPEC final will be equal to is equal to 1 to n, if n is the number of programs, SPEC I raised to the power 1 by n. Right? ठीक है? So you can go on SPEC web page and you can figure out more about these things. But this is the basic formulation. Right? Is it okay? Is this okay? Hello? Hello?
Yeah, sir.
सर जो
Is
आपने
this
पहला
okay?
जो लिखा है SPEC रेटिंग, तो मतलब वो एक पार्टिकुलर है ना, जैसे SPEC कोई आई.
Actually, this should be written as SPEC I rating.
हाँ.
Actually, this should be written as like this. And this is SPEC final rating. ठीक है ये?
I for instruction, one instruction, second instruction, third instruction.
It's not instruction, it's program. So we have n number of programs, set of n number of programs. उन सबको हम टेस्ट कंप्यूटर पे चला के देखेंगे और रेफरेंस कंप्यूटर पे चला के देखेंगे, और उन सब के लिए SPEC की वैल्यू निकालेंगे और उन सब का फिर मल्टीप्लिकेशन करके और nth रूट लेंगे. Getting it?
Yes. Yes, sir.
Are you able to understand this?
Yes.
Any questions about this? Yes or no? Huh? Any questions? Okay. So this completes your first unit of the book, Computer Organization. We'll stop here today. In the next class, we'll start discussion on one's complement, two's complement, and addressing and other things. The introduction part is just finished. If you have any question till now, you can ask now. You can write me a mail, or you can ask in the next class. Is it okay?
Sir, JNU may or your regular one, which would be you preferable to you? Sir, you have two mails, right? One your personal and one JNU.
Mail on any mail ID. That is fine. I check all the mail IDs.
Okay, sir.
Okay. Is it okay?
Yeah, sir.
Okay, so you'll stop here today. We are just closing the class little early today. So in the next class now we'll meet. And in tomorrow's class, we'll discuss something about what we have to discuss, what we have to do in the lab session of this. And then maybe at some point of time, we'll do a offline lab if it is open. Otherwise, you have to go with this online lab only. Fine?
Sir, for the reference, computer organization first chapter is finished. We can
Yes.
refer that. Okay, sir.
Okay. I have by and large followed book only. I am not going out of the book. So if there is a confusion, please feel free to ask in the class, out of the class, anytime you want. Fine?
Sir, which book you are following?
Called Amateur. Okay?
Okay, sir.
Okay, bye.